Today we're doing the fourth set of notes and we're going to be discussing graphing radicals. So for our first example, the problem is the square root of x. So we're going to begin by making ourselves a little t-chart. So I'm going to draw my xy table. And we're going to talk about what values I'm going to put on the x side. So typically we're always going to put our values that we can actually square root. So for this case I can take the square root of 0, of 1, of 4, 9, and so forth. When I plug in my numbers into the square root of 0 is 0, the square root of 1 is 1, the square root of 4 equals 2, and the square root of 9 equals 3. So I'm going to take these points and plot them. So I have 0, 0 is my first point, 1, 1, 4, 2, and 9, 3. Now, you're going to notice that this graph is only growing in one direction, which is slightly different than any graph we've done thus far. Up to this point, our graphs were always growing kind of in both directions. But this is what we call, like, right here, this point is our ending point, if you will. So remember, our domain is our x values going left to right. So this would be 0 to infinity, because that point right there, again, is 0, 0. And domain is your x values. Range is my y values, which is also going to be 0 to infinity. For the next example, the table is a little bit more difficult to do because I can't necessarily just plug in my basic values that I can take the square root of, because I'll end up getting decimals. So to begin, we're always going to take whatever this number is and we're going to write the opposite number. That's always going to be our first value. And then really it kind of just becomes some trial and error, or we're going to discuss in a moment that you can use graphing calculators to obtain these graphs. So the next number I can put in is a -2. I'm not going to use -1 because if I put -1 here, -1 plus 3 is 2. And I can't take the square root of 2, so I'm not going to use that number. 1 is the next number that will work because 1 plus 3 is 4, and I can take the square root of that number. And let's kind of start us off there. Actually, we'll put one more. 6 will be the next number because 6 plus 3 is 9, and I can square root that. So here I have -3 plus 3 minus 5. So this will give me 0 minus 5, which is -5. The next one, I'll get the square root of 1 minus 5, which will give me -4. When I substitute in the 1, I get the square root of 4 minus 5, and the square root of 4 is 2, so 2 minus 5 is -3. And when I substitute in the 6, I get the square root of 9 minus 5, and 4 minus 5 is -1. So to plot these points, I go left 3 down 5, then I go left 2 down 4. I have a 1, -3, and a 6, -1. Nope, that point's not right. Let me come back to my table. This is not correct here. This should be 3 minus 5, should be -2. And there is our graph. Again, the point that's of importance is your vertex, or your starting point, if you will. And that point is -3, -5. So for my domain is going from -3 to infinity. Again, the x values, and your range is -5 to infinity, which is my y values. So in general, the standard form of these equations is y equals a, the square root of x minus h, and then we have a plus k on the outside. So these three would be numerical values. Typically, our a value is going to be 1. Right below standard form, there's kind of a few sentences. So h shifts your graph left or right, and you might want to jot down that it's always opposite, meaning if it says plus 3, that means we're going to go left 3, and if it says minus 2, then that means we're going to go right 2. K shifts your graph up or down, and this means it will go the same. And if A is negative, the graph is reflected over the x-axis. Now, for the next graph, again, you're going to have this equation, the square root of x minus 3 plus 2. So we're going to discuss, well, instead of creating a table, what's an easier way to do this? Obviously, if you're in school, you'll have access to a graphing calculator. If you're at home, you're not, so we'll talk about what websites we can use. But one thing you should understand is that these two numbers are important. This number is going to shift us opposite, the other one will shift us the same. So your graph is going to be starting at the point of 3, 2. Again, opposite of the negative 3, same as the positive 2. So you're going to direct yourself to a website called Desmos. So you can just go in your Google screen and search desmos.com, and it'll take you to a graphing calculator. You might have to click the button that says graphing calculator. This keyboard is located down here. When you click the keyboard, this whole thing will pop up. Your square root button is right here. So there's where you will get your square root. The x is important to use, and obviously plus or minus. This button right here is also important because for this equation, after I wrote x minus 3 underneath the square root, I needed to hit this right arrow so that the plus 2 was outside of the square root. So make sure, make sure that if there's numbers outside the square root that they are outside. If you ever have a negative in front of the radical, which you will in the next problem, you would use this button right here. So the graph is, you're going to obtain the graph from this website, so go ahead and plot these points onto your notes, and now we'll go ahead and answer the questions. You can obviously hit pause to copy this into your notes. So my domain is my x value, so this point right here is at 3, 2, which means my domain is going from 3 to infinity because it'll go forever to the right. My range is going from 2 to infinity. In letter C, they're asking you to find the slope from 3 to 4, so I'm going to put a dot at 3 and I put a dot at 4. So when x is 3, I have a point right here. And when x is 4, I have a dot right there. Well, my slope in this case will be a positive 1 because I'm only going to be traveling up 1 over 1. So my slope is going to be 1. In terms of x-intercepts, this problem has none because this graph is not crossing the x-axis, nor will it ever. So in this case, it is NA. Will this always be the case? No. Sometimes your graph will cross the x-axis, sometimes it won't. It depends. It changes for every picture. Letter E says y-intercept. Again, I look at my graph. It's never crossing the y-axis. So again, this answer is NA. Some graphs will have them, some will not. G and H says max, relative max versus relative min, and I just realized I wrote them in the wrong spot. So on your paper, this one says min, and this one says max. So the key point, again, that you're going to be looking at is your vertex. So this point right here of 3, 2, and you need to ask yourself, is this the lowest point of the picture or the highest point? This point's the lowest. Everything else is getting higher, so our relative max is happening at 2 because this y value is at 2. In terms straight lines, this is your minimum because everything is significantly higher than that, which means you don't have a max. A lot of times students will say to me, but what about all these points? They're obviously higher. This is true, but every point gets higher and higher, so you can't pick one that is the highest of them all. So at this point, I'm going to stop. You can try the next one on the page. Try the next one in the example section and then the practice on the next page. And then at that point, you can stop in the notes.